So today we're going to be talking about all the different electron domain geometries that we learned about in Chapter 9. This first diagram here has, as you can see, with this eraser kind of being our central molecule here, has three total electron domains. This molecule is an AB2 type of molecule with the geometry of a trigonal planar. This molecule has one lone pair of electrons. Its geometry is considered bent. An example of this type of electron with this type of molecule and this geometry is SO2. Now we can add one more domain to this example here, and we're going to put that right there. And now what we've moved from 3 domains to 4 domains, which changes the type of molecule from an AB2 to an AB3, which then changes the geometry from a trigonal planar to a tetrahedral geometry. However, this molecule still has one lone pair of electrons, but it has a trigonal pyramid type of geometry, molecular geometry. An example of this type of molecule could be NH3. With this same model, we can also have a type of molecule that is an AB2, same domain geometry as the AB3, still tetrahedral. However, because it's an AB2, it now has 2 lone pairs of electrons. However, furthermore, this model has a molecular geometry similar to the molecule that only had 3 domains, and that molecular geometry was bent. An example of this type of molecule is H2O. Now we can add one more electron domain to our diagram here. I'm going to put this one right on the top. Now this diagram here now has 5 total number of electron domains. An example of this type of molecule could be an AB4. The electron domain geometry is a trigonal bipyramidal. It has one lone pair of electrons, and this molecular geometry is seesaw shaped. An example of this is SF4. Taking this same diagram with the 5 electron domains, you can also have a type of molecule that is an AB3. Again, exact same electron domain geometry as the trigonal bipyramidal, but instead of, like I said, moving from the AB4 to the AB3, you now have 2 lone pairs of electrons. This molecular geometry makes it T-shaped instead of seesaw-shaped. An example of this molecule is ClF3. Again, using this exact same diagram with the 5 total electron domains, you can also have a type of molecule that is an AB2 that has the same electron domain geometry of the trigonal bipyramidal, but instead of having 2, now has 3 number of lone pairs of electrons, and that moves from a T-shaped molecular geometry to a linear molecular geometry. An example of this molecule could be IF2 negative. Now, moving into our final diagram here, I've now added the 6th electron domain, and an example of this molecule, this type of molecule could be an AB5. This geometry is considered octahedral with 1 lone pair of electrons and has the geometry of a square pyramid. An example of this molecule is BRF5. And using this exact same diagram, we can also have a type of molecule that's considered an AB4. Again, has the exact same geometry as an octahedral electron domain, but now has 2 lone pairs of electrons. And because we've moved from the AB5 to the AB4, the molecular geometry has changed from a square pyramid to now a square planar. An example of this type of molecule could be EXF4. Now, obviously, it's very tough to kind of show the complexity and the geometry of of molecules using such crude resources. However, hopefully you're able to see that, as you're adding domains, how that changes the electron geometry in a sense. We had 3 domains and it was a planar. It was simply one dimension. But then you add another domain and it moves up from a trigonal planar to a tetrahedral, and then you add another domain and it goes from tetrahedral to trigonal bipyramidal. And so when you add these domains, it changes not only the shape, but more importantly, it determines how these molecules behave, especially when we're looking at the number of lone pairs of electrons, because those electrons are going to really help dictate how these molecules are going to interact and exist in nature. And so, especially when we had 5 electron domains, that significant. If you move from an AB4 to an AB2, you've increased the number of lone pairs from 1 to 3, and that significantly changes how those molecules interact in nature. So hopefully I was able to show you guys what that looks like using these balloons.